These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There is a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website. Thanks. Well, this is a predict the products problem. Okay. What type of mechanism are you doing?
An E2.
Okay, that's fine. Now let's talk about that some. The main reason I wanted to go over this was that one of the best things you can do for yourself is still to learn how to use the SN2 E2 table to predict what reaction we're going to have. Do you happen to have that handout with you?
I do.
Good.
Or actually, and I know we have a good base,
right?
Strong base.
So let's find where we are in the table.
Says SN2.
That's right. That would be my prediction here.
Okay.
That's right. I think your guess was E2. Now the reason that we're not going all the way over to E2 is we don't have a bulky base.
Okay.
We do have a strong base, but this is not bulky enough to be considered bulky.
Okay.
In fact, you've probably seen one main bulky base. Do you remember what the main bulky base is that your instructor uses?
I'm just wondering, what about the solvent? Is that going to affect it at all?
Yeah, the solvent won't have any effect. The solvent was just put in here as a technicality. One thing to notice is that if you look at the table never talks about the solvent.
Sure.
And the reason is that usually on test questions, they don't make the solvent the deciding factor.
Okay.
In the lab, maybe the solvent might be the deciding factor, but that would be too subtle for an introductory course. So on test questions, they usually don't make the solvent the deciding factor. So the solvents, here we do have a protic solvent. That's not going to turn out to play any role in the problem. It's actually pretty typical when you're using a base to use the protonated form of that as the solvent, because that way we know it won't compete in the reaction. You can see this solvent here is just a protonated version of the base. Okay. So it's not going to actually play any significant role.
Okay.
That's right. Okay, so yeah, whether we have a protic or an aprotic solvent is usually not the decisive factor on test questions. Instead, we can use the table. All right, and by the way, I was asking you, what is the typical bulky base that we use?
Turbutyl oxide.
Yeah, but this is not that bulky. It's not turbutyl oxide.
Even with all the other stuff hanging around?
Well, let's see. So you worked that out pretty good. Which row are we in here?
We're right here.
Yeah, because we're on a primary. Now, there's not that much other stuff here because the beta carbon is only secondary, and you worked that out well, so that's right. You're right, if the beta carbon was tertiary, that would be enough extra steric hindrance to knock us down to here. So this is that would knock us down to here. So we are kind of on the borderline here. This is a tricky problem. This is where you really need a full table like this to actually work it out. But now we're not saying there won't be any E2 here, but the major reaction that we would predict would be SN2. Okay, so yeah, the table gives us the right answer here. There's not too much steric hindrance on the alpha carbon because it's primary. There's not too much steric hindrance on the beta carbon because it's secondary rather than tertiary. And there's not too much steric hindrance from the base because it's not as bulky as turbutyl oxide. So let's show the mechanism for an SN2. One, two, three, four, five, oxygen. 1, 2. So at the same time, I'm going to write this with bond line notation. You wrote it with this notation, which is fine. So we just have to make sure we don't add or drop carbons. 1, 2, 3, 4, 5 carbons over here. 1, 2, 3, 4, 5. You got that right. And then 2 carbons in the nucleophile that's attacking, connected by the oxygen. And that would be the product. All right. Let's try to predict the product with these reagents.
What would be the nomenclature for that product then?
This one here?
Yeah.
That's a good question. Let's back up and get the nomenclature. Well, first of all, do you know what type of functional group this is?
It's an ether.
Okay, that's good that you came up with that. It's an oxygen connected to 2 carbon chains. That's an ether. Ether nomenclature can be tricky. It depends actually on how your instructor wants to name them. So different instructors will name them different ways. I don't know if this is covered in the second language book. So the IUPAC system would be to say that this you pick the longer carbon chain as the main chain.
Okay.
So in the IUPAC system, this would be the main chain. Why am I starting the numbering here? Because here's the functional group. That would be pentane. And then we name this as a substituent. Now, how many carbons are there on this substituent?
It would be an ethoxy.
You got it, that's right. So this would be 1 ethoxy pentane. We have to put in the 1 to show where the ethoxy group is. Do you remember your instructor using this type of naming?
Yeah.
Okay, so it looks like your instructor might be using this. So this would be 1. So the key thing is we treat the ether oxygen as a substituent. Okay. We treat the ether oxygen as a substituent, and we treat the longer carbon chain as the main chain. The common name for this would just be ethyl pentyl ether. The common name is much easier. You could just call this ethyl pentyl ether, but it looks like your instructor wants you to know the IUPAC system, so this is the IUPAC system. now we're doing this particular product.
I predicted E2.
Right, let's confirm that in the table, first of all. Where are we in our table?
We're in a bulky base.
Yeah, let's find the exact right cell.
Strong, bulky on the first degree.
Right. Notice how, compared to the previous problem, in the previous problem we were here, and now we just moved over one to the right. There's a little bit more steric hindrance, and that's bulk. We know that the big obstacle to SN2 is steric hindrance. We've shut down the SN2, and we moved into the E2 region over here. And it looks like we drew the right product there.